So hello viewers, this particular diagram you are seeing on the screen, that is the traditional state transition diagram of the BGP once the device is configured, and there are certain packets that might be exchanged between two devices when the BGP is configured. So in today's video we are going to see that what are the packets format, or what are the distinct packets that will be exchanged while forming a neighborship. So yeah, let's get started with this video. So if you are new to this video, probably or if you are new to this channel, and this is what we have covered in the past video. So the first video that we had for the BGP introduction and very high level overview. So if you are not aware about BGP, and if you might want to watch that video, because in that video we have explained this state transition diagram, so you can just watch that video. I might have a link over here in the I button, or you can get the link from the description box. So do check out that video if you're new for the BGP protocol. And also in the last video we have seen some troubleshooting advices that you might be asked while appearing for any interviews. So these are the good questions that you might get, and you should know this. So if you're learning BGP and configuring BGP, you should know this. So now let's look at the packet formats. So this is the basic header of BGP message. So you can see over here that the maximum length of the BGP message, any BGP message, that is 4096 bytes, and header is the minimum header length is 19 bytes, which is keep alive message. So technically this, if you see whatever you are seeing on the screen, that is common for all the BGP messages. So this will be carried with all the BGP messages, whether it is keep alive or BGP updates or any other message. And what will change is this type. So this type will decide what is the BGP message post this BGP header. So open message, update message, notification message, keep alive message. So whatever we have seen in the previous state transition diagram, so those will be can fall as in type over here, and which is 1 byte value. Then this is length value, where you will have a length of the total length of the BGP message, and marker. So this is very important, 16 octants value this marker is, and this indicates whether the information synchronized between BGP peers is complete. So this field is used for calculation of BGP validations. So if no validation is used, this field is set to ones. So all ones, basically 16 octants, all 16 octants are 11111, and this are the BGP information, such as certain values that will be kept over here, and if those are matched, then and only then we will have a BGP neighborship. So that's the basic BGP header format. We'll also see the actual header, packet capture files. So the second message after we start or we configure the devices, that is BGP open. So after the TCP session has been established, so the first BGP message that will be sent is BGP open. So this is typical BGP open message without header. So header is the previous packet format that we have seen, and after that this will be the BGP open message. So with the BGP header, this will be the message. These are the fields. If these are the fields that are included in the BGP packet or BGP message after the BGP header, so this is typically BGP open message. So version field, basically it includes the BGP version, and if you see over here 0, 7, 15, 23, 31, so these are bytes, and first octant, basically second octant, third octant, and fourth octant. So that's how it is structured. Now my autonomous system, so that's the ASN number of the sender, hold time, which means the hold timer set by the sender of this message. And hold timer is basically nothing but the time if we didn't receive any keep alive message before this timer has been expired, then we consider that neighbor is not up, or there might have certain problem with that neighbor. So we mark it as in not established neighborship if the hold timer is expired. So that's the rule of hold timer. Then BGP identification. identifier actually. So that is nothing but the router ID that we set during the BGP configuration. We'll learn how to set all those stuff in the Cisco Packet Tracer, or if we are simulating in the NS3 in upcoming videos obviously. Now this is the optional parameter length, and these are the optional parameter variables, and these two fields are variable. So basically whatever the option that we want or that might have been configured using the CLI, that will be set over here, that will set by default over here. And there are certain things. So the optional parameters, so they consist 3 categories: parameter type, length, and values. And all this differs, and all this is configured or sent dynamically based on the configuration that we might have. So yeah, this is the very important stuff for BGP, although we'll talk on this in future slides, but just to give you an overview. So whenever we send certain BGP updates, so on those updates we have certain address family identifier and subsequent address family identifier, and people also call it as FE and SAFE. So these are the values. So for FE1, which means we have IPv4 family, and then subsequent address family, so with FE1 and SAFE1, so that means the address is IPv4 unicast, or let's say FE1 and SAFE2, that means IPv4 multicast. Then FE1 and SAFE 128, that means VPN, so L3 VPN basically, so IPv4 VPN. So that's how this translation of certain address is sent on the BGP update message, that will be happening in the background. So that's the very important part for BGP. And also not to worry about if you don't get this at this particular moment, because we'll talk about this in future. Yeah, and this is the BGP update message. So BGP update message is very large, and to understand that it's totally hard if you don't have any actual packet capture. We are going to see packet capture, the real packet capture, after we finish all the basic packet formats. But just to give you an overview, this is the typical BGP update message. So first, after the BGP header, we'll have this unfeasible route lines. This is basically 2 octants, so 0, 7 and 15. These are the byte indexes, so first octant and second octant. Then we have certain withdrawn routes, and this is variable, so if you want to withdraw routes, then those will be sent over here. Then total path attributes, so there are certain BGP path attributes that we'll talk in the future, but just to give you an overview, this will reside over here. Then path attributes, so total path attributes will so based on this value we will understand what is the length of this path attribute and stuff like that. Then we'll have a BGP update, so what are the routes that we want to send. So and this section is also variable, so according to what we have in our database to send to certain neighbors, this field might vary. So that's the basic BGP update format. So yeah, this is the basic packet structure of BGP notification without header obviously. So after header, if these are the fields, then this is BGP notification message. So BGP notification message is used to translate certain or communicate certain errors that might have been configured, or that might have been happened during the configuration, or during, if let's say two devices are trying to form a neighborship but there are certain errors. So these are the this is the packet format that is used to communicate those errors. So based on this error code and error subcode, so just now we have seen FE and SAFE stuff. So this is same. So first is error code. So yeah, obviously this is first octant, second octant and third octant, and this is the bit indexes. And if you see error code 1 over here, that means message header error. And also, if let's say error subcode is 1, that means connections are not synchronized. Then if let's say error subcode is 2, so incorrect message length. So that's how it is translated to the devices, and that's how they show you certain notification or certain errors while using any show commands in the CLI. And yeah, so these are just the 2 example error codes, but yeah, we have more error codes for BGP notification message, and you can check out on internet. So yeah, this is basically BGP keep alive message. So BGP keep alive message is nothing but the BGP header with type value 4. So when we have 4 over here, we don't need to send any other certain structures. We just need this much of packet, this much of file, or this much of data. And with this type value 4, this is BGP keep alive message, and these keep alive messages are used to keep the neighborship alive. So we will have if let's say two devices are communicating or they have formed the neighborship, then after certain interval, or usually it is 1 minute or 60 seconds. So after every 60 seconds, the keep alive message is sent. So both devices will send each other a keep alive message, and they'll by receiving those messages, they'll know that so the neighbor is alive, and we need to still exchange the route. So that's the use of this keep alive message. So if you want to know about certain in detail stuff of BGP packet format, so I have kept this link of this, so you can go to this link. I'll keep this link in the description box. So basically this is having detailed explanation of BGP packet that what we have studied. So all the images that I have took from over here, and if you see BGP notification, so all the notification error codes you can see over here, and those all the packet example packet formats you can see and observe over here. So just refer this if you have any doubts, and you can pin this URL for later if you want to study more about BGP. And it's not just only for BGP, so there are so many protocols that you can see to what are the packet captures that might be using. So that's the very cool stuff. You can have this URL, I'll ping this in the description box. So now let's look at the actual packet formats. So this is very cool website. Again, I'll have the link of this URL also. And if you see, this is the BGP packet formats, or so there are two devices basically, 192.168.12.1 and 12.2. if you see the first packet over here, so they two are trying to form a neighborship. So if you look at, or if you remember the state transition diagram, so you can clearly observe the state transition over here. So the first three packets, if you see SYN, SYNEC and acknowledgement, so these are the TCP handshake. So this is the packets for TCP handshakes, TCP handshake, not handshakes. So these three packets are used for TCP handshake between these two devices, 12.1 and 12.2. So if you see the port number 179, and that is used for basically BGP. So after that, they will we have seen they will send an open message, BGP open message. So this is the BGP open message, and you can see and you can observe all the fields that whatever we have seen right now. So this is the marker length. So for BGP open, the type is 1. You can clearly see that. Version, that means BGP version is 4. My ASN, so this is ASN number is 1. Hold timer, which means 180 seconds, so that means 3 minutes. And BGP identifier, so the router ID is 1.1.1.1, and that is for source device. So for 192.168.12.1, the router ID is all ones. Then there are certain optional parameters. So you can see all these optional parameters that what might we have configured on this 12.1 device. Now after that, if you see, the acknowledgement has been sent for this BGP open message, and open message also has been sent by 12.2 to 12.1, and you can see the packet format is same. Now after that, we will have a keep alive message. So 12.2 is sending in keep alive message. So if you see, keep alive message is type is 4, marker and length. There is no other fields, just this type, marker and length. So marker is all ones basically, so we do not have any settings. And keep alive, as we have seen, for the type value 4, which is keep alive. Then we have this so this is the acknowledgement for the open message again. So after that, we have certain or couple of keep alives. Then we have BGP update message. So in this BGP update message, we will send the routes. So these are the fields, so path attributes, then network layer reachability information. So we are advertising 1.1.1.0/24. So that's the address that we are advertising. We have second also. Okay, so here we don't have any routes that we are withdrawing also, and there are no routes that we are sending also. So this is the typical BGP update format. Then we have another keep alive message. So keep alive message will send so there will be always keep alive message you will seeing over here, because every certain amount of certain amount of time interval, keep alive message will be sent. Then we have update message from 12.2 to 12.1, and you can see that it is advertising 222.0/24. so that packet structure, you can see that is also similar, but the routes that are advertised is different. So that makes sense because both devices will have different routes. And yeah, this is the acknowledgement for whatever the BGP update message that we have sent. So yeah, this is the very good website if you want to see the actual packet captures. And I think with this we have covered the BGP history and BGP packet formats. I hope that you have got the idea about what are the BGP packets, what is the state transition, and how the packets are exchanged to form a neighborship. So that's it for this video. We'll meet in the next one. Till then, keep learning, keep exploring.